Hi Year 13. In this lesson, we're going to be going over our third example of a volcanic eruption. You'll remember I said that this is the one that you can use if you want to talk about the secondary impacts of volcanoes or, erupting, or whether you want to talk about a tsunami event. So what we're going to do is identify how tsunamis can be caused by earthquakes and volcanoes, and then categorize the impacts of the eruption, and we'll be thinking very briefly about how you can compare these three eruptions in, say, a 9-mark question. So what you're going to need for this is the back of the seismicity booklet that I gave you in our last lesson, which looks like this, and it has tsunamis information on the back. And you're also going to need the worksheet where the front looks like this and the back is space for you to write the 9-marker. It's the worksheets that I gave you in our Monday lesson. So if you could get those ready, you're going to be using those and making notes throughout this lesson. So the first thing to make a note of on your sheet is that what we are talking about in this eruption is going to be a tsunami which has been triggered by volcanic activity. But there are 4 causes of tsunamis, usually seismic activity, so earthquakes that happen beneath the ocean, otherwise what we call submarine seismic activity, submarine being beneath the sea. And seismic obviously being linked to earthquakes, as we talked about on Monday. So that's the most common cause of tsunamis. However, they can also be caused by landslides. So if you see in the bottom left-hand image here, in the top right, you can see how volcanoes can trigger movement of water, and much more rarely, but it has happened in the Earth's history, is meteorites striking the ocean and then triggering movement of vast waves in all directions. So those are the main 4 causes, and obviously in this lesson we're going to be looking at the top right one, which was the tsunami which was triggered by a volcanic eruption. Now you have all these notes on your page, so you don't need to make any notes on this, but it's just pointing out that tsunami waves are very different to normal waves. They're not the same as tidal waves, which can be large waves. They can be meters tall, but tsunamis are, because they are triggered in a very different way. They're not triggered by movements of the wind, for example, or tides. They have very different characteristics. So one of the features is that their wave height is actually very low, and in fact, if you were, I'm just going to see if I can draw onto this here, if you were a little boat out at sea here, that's a boat, there you go. You may not even notice a tsunami passing beneath the boat, and it's only when the waves reach the shore, as we'll look at in a second, that the amplitude of the waves increases. They also have really long wavelengths, so it can be up to an hour between one wave reaching a shore and the next wave reaching the shore. Despite the fact they travel very quickly, there can be that big delay. And they consist of a series of waves. The first isn't always the largest, so it's something to be aware of, that just because one tsunami wave strikes, it's not necessarily that is the worst over. So how does a tsunami actually happen? Well, the first thing that has to occur is that there's got to be some shift on the ocean floor, usually volcanoes or earthquakes, that causes a movement of the ocean floor. Usually that vertical displacement upwards will also displace the water column above it in a vertical direction. This can happen really quickly and it generates lots and lots of energy within the water. Then the energy from the earthquake actually causes a train of what we call oscillatory waves that develop over the ocean surface, and they start traveling outwards in all directions at speeds of up to 500 miles an hour. This is like what I said in the lesson on Monday, where this is like you're dropping a pebble in a pond and it ripples out in every direction. Now, as they travel, the wavelengths of the tsunami continue to grow, with the wave periods, that's kind of the distance between the peak of one wave and the peak of the next wave. They vary from anything, like I say, from 5 minutes to more than an hour. But as they approach the shore, because the distance between the top of the surface of the ocean, sea level if you like, and the seabed, because that distance starts to decrease or narrow, there's increasing friction as the waves approach the shore and they collide with the rising seabed. So as this velocity decreases due to the friction, the wavelengths start to shorten and the amplitude increases. Amplitude meaning basically the height of the wave. So the waves start to get higher and taller as they approach the shore. So out to sea, they might seem like nothing, but then as they get closer and closer to the coastline, they will start to grow. Now, the impact of this is that when they do eventually collide with the shore, the water flows inland very quickly. It can wash away people, it can uproot trees, it can wash away property. The thing to be absolutely clear on, if you're ever at the coastline and there is a tsunami warning, or you notice the wave retreating very rapidly, you must get to higher land, because tsunamis, if you are in their path, they can easily wash people away, and unfortunately people do and have died as a result of these on several occasions in the past. So it is something to be wary of if you're ever, especially around the Ring of Fire, because this is where tsunamis are most common. So if you're ever in a tsunami prone zone, make sure you're aware what the tsunami siren sounds like, or what the kind of closest evacuation point is, or the area of high land nearest you. All right, so we're going to be focusing now on the specific Hunga-Tonga Hunga-Ha'apai eruption, and we'll talk later about why it's got that name. So you're going to need the other worksheet that I gave you now, and what I'd like you to do is locate where Tonga is on that world map, and it's actually going to be right along the edge, because it's kind of a small island in the middle of the Pacific. So locate New Zealand first, and then see if you can locate Fiji, and it's just to the sort of southeast of where Fiji is. So maybe do a little star on your map to mark where it is now. And another thing you might want to do on your map is just use a highlighter to kind of outline where the Ring of Fire is and locate Tonga within that. So as I said, it's just this kind of northeast of New Zealand, or the southeast of Fiji, but it is located along that Ring of Fire, sort of which surrounds the circumference of the Pacific Ocean. So maybe mark that on now. You might want to mark on a couple of the other countries as well. In particular, the ones that have been added onto this map, they're going to be significant later in the lesson, because they were also countries that were affected by this eruption. So especially Chile, the US, Japan, New Zealand and Australia, it'd be definitely worthwhile adding those on. So the reason we're studying this eruption, you'll note that the spec says you only need to know one eruption event, but we've obviously done 3. And the reason we're looking at 3 is so that you can have a bit of context about each of them. You can compare them if you had a 20 marker. So it's just going to give you a little bit more to talk about if volcanoes does come up. But also, this one was a really unusual eruption. And we'll look in this later in this video at kind of reasons why. One of the unusual factors was the scale of it. So if you take a look at this top right image, you can see that that is actually France, a satellite image of France, and the size of the eruption has been kind of taken from Tonga over to France. So just so you can visualize and get your head around the scale of it, you know, somewhere that perhaps is a bit more familiar size-wise or scale-wise. So you've got a box on your sheet which says, why was the eruption so special? Well, it was the scale of it. The other thing was that it caused a sonic boom, and you probably are more familiar with sonic booms being caused by aircraft when they travel very fast. But it was so loud that it could be heard in New Zealand, which was about 2,383 kilometers away. And again, just for context, I've just drawn onto Google Earth here what that distance is. That is actually the distance from London to Ukraine. Okay, that's how far 2,300 kilometers roughly is. So it was massive. It could be heard from a long, long way across the Pacific. It just gives you an idea about just how big the scale of this event was. Okay, so why did the event occur? Why did the eruption occur? Well, I'm just going to take you back. Do you remember when we looked at our seismic tomography and we were looking at evidence of subduction zones by looking at the different tomographic maps? And we did look at Tonga and the fact that the Tonga Trench is being created where the Pacific plate is subducting into the mantle beneath the Australian plate. And as a result of that, we have the melting of the subducting Pacific plate and the Tonga volcanic islands that are created as a result. So we're just kind of putting it into its tectonic context here. So it's a destructive plate margin, and that's the kind of general cause of why the Tongan Islands exist. So let's hone in a little on the specific islands that we're talking about here. So we're talking about two islands. One was named Hunga-Tonga and one was called Hunga-Ha'apai. And to get a little bit of context about this, we're going to have a look at the bathymetry. Now, you should remember from coasts that bathymetry is the depth or the shape of the water in the oceans, the sea or the seabed, in lakes. And here we have a kind of GIS image which shows the bathymetry data from various sources overlaid on a satellite image. Now what you can see here, the kind of darker areas show you the parts of the islands which are exposed above the water or were exposed above the water, but most of the volcano, so all of the areas which are in orange, green, blue and purple, that is underneath the seawater. So they're using satellite imagery to work this out. And it just gives you an indicator of what the volcano looked like beneath the sea. I'm going to show you another view of this in a second. So here's another way of looking at this, and same thing again, you will just see those kind of darker parts on this graphic. Those are the parts of the island which were exposed above the water, or they were kind of rising above the surface. The caldera, which is the name of the large volcanic crater, you will see it is much, much bigger. So the parts that we can see above the ocean water, it's only a small part of the much, much larger volcano, which, and you can see a bit more about the bathymetry sort of here. So this kind of extends right down to the ocean floor. And then this is the only part, these two islands, so Hunga-Tonga and Hunga-Ha'apai, these are the only two islands that were exposed. So you've also got a section on your sheet where we're going to fill in a kind of fact file with various things like the volcano type, the rock type in a moment. But one of those bullet points says first eruption. And the first eruption started to happen about the 14th of December in 2021. And there were several small eruptions that then happened throughout the rest of December and the start of January. And you can see, again from these GIS satellite images, just how the shape of the volcanoes started to change. So a little bit more about the volcano itself. This is going to help you to fill in the fact file on your sheet. So the volcano type was what we call a submarine volcano. So it's just one that's formed under the sea with some fissure eruptions. So it's got an elongated fracture or crack at the surface from which lava erupts. And you will see in this image here the extent of not just the volcanic island, which is above the surface, but also the yellow outline, which shows the extent of the caldera, which is underneath the sea as well. The rock type is andesite or basaltic andesite. The tectonic setting, as we said, was a subduction zone, so a convergent destructive plate margin. There's no people living here. People had visited the islands to go walking in recent times in the lead up to the eruption, but there were no people living there. And in fact, the nearest populations were about 5 kilometres away with only 200 people or so. Within 100 kilometres, though, much, much more people live along the various Tongan islands, so up to 86,000 people within 100 kilometres. So a little bit more about the islands themselves. Now, before 2015, these two islands had actually been separate, but then in 2015, there was an eruption which led to them becoming a single island landmass. And this remained the case until about April 2021, and this is what it looked like. So you can see the elevation above sea level, and they were completely connected, so you could technically walk from one side of the island to the other due to these connections. But I'm going to show you next how this changed. So by early 2022, there'd been a series of eruptions that had effectively kind of obliterated the island, and it had removed the connecting landmass. And then by January 17th, all that remained were two small landmasses, once again separated by the sea. So I've got another satellite image here just to show you that a sort of before and after of what we just looked at. So on the 8th of December in 2021, this is what the islands look like. And I'm just going to press play and you will see how this changes by mid-January of the following year. Okay, so 16th of January, this is what it looks like, and you can just about see the two islands. If I annotate here, there you go, there's one of the islands there, one of the islands there, but you can see much of it has been completely obliterated. So looking at this kind of before and after, one of the reasons why this happened is because it was a very explosive volcano. In fact, it measured 5 on the VEI index. And you can go back and you can compare how that contrasts with our Icelandic eruption and our Nyiragongo eruption. In fact, the last time there was an eruption this explosive was actually in 1991 in Mount Pinatubo. So they're fairly rare. 30 years ago was the last time this sort of scale of eruption happened. So now we want to start thinking about the tsunami that was triggered by this event and sort of what happened, some of the impacts. And to do that, we've got to think about what type of eruption this was. So not what type of volcano, but what type of eruption. And you remember we looked at various eruptions. So we looked at Hawaiian eruptions, Vulcanian eruptions, Plinian eruptions. But this is one we didn't actually talk about. It's something called a Surtsian eruption. And it's named after a location called Surtsey, which is just off Iceland. So it's kind of common there. And it's an explosive style of eruption that takes place in shallow seas when we get this rapidly rising, fragmenting hot magma interacting explosively with the water. There's something that we call hydromagmatic. So you can see the words hydro, water, and magma in there. And so they're violently explosive as a result of the kind of vigorous interaction between the rising magma and the lake or sea water. And you can just sort of see an annotation of what this looks like on the left there. So what caused the tsunami to happen? Well, there were actually 3 theories, and scientists weren't sure for a long time because this was such an unusual event, and they didn't really know what had caused such a vast scale eruption to happen. The first theory was that a landslide had happened. So like we looked at earlier, where the caldera becomes unstable, partially collapses, and then triggers a movement of water. The second theory was the caldera collapsing, so the magma chamber emptying, the volcano falling in on itself, causing a huge eruption and large displacement of water for marine volcanoes. And the third theory was actually that the water was moved by a sonic boom. So the shear pressure expelled from the what we call phreatomagmatic eruption on a pressure scale high enough to forcefully displace the water. So now researchers believe that the ash and rock ejected from the caldera fell into the sea and rushed down the flanks of the volcano as hot, turbid currents called pyroclastic flows. These moved out far along the ocean floor. They're the prime suspects for triggering the tsunami. So possibly a combination between theory 1 and theory 2. However, the sonic boom was significant, and we'll look at that later. So just following on from that, this graphic shows some of the knock-on effects of the eruption. So the force of the eruption would have generated tsunami waves, and in fact there were islands nearby which had been created by previous volcanic activity that were destroyed as a result of those. But also there was a huge ash cloud. So this spread up to 160 miles in diameter, rose up to 19 miles, and it was pretty significant actually across the whole of the Pacific Ocean, for a short while. So moving on to thinking about the impacts now, and you've got a box where you can write about the local impacts and the global impacts. And one of the ways they assessed the impacts was looking at GIS. So what this graphic here shows is what they could see using satellite GIS data in terms of the changes that have been made to the landscape. So one of the villages in Tonga that had been really affected by this, you can see 2 satellite images from before and after the tsunami there. The grey area is where there were clouds, and so they weren't able to collect satellite data. But you can see that in the top sort of left of this graphic, that various houses were covered by ash, and I'll talk about that a bit more in a moment. 41 structures were damaged, and this was just in one small village. Another before and after image you can see here of where the tsunami had inundated a local village and the shoreline that had been affected, and how some of the structures had actually been completely destroyed. Certainly some trees had been uprooted and removed. Again, this was along the Ha'apai division in part of Tonga. So in addition to studying satellite images, they were able to look at aerial photographs and see some of the damage that had been caused again to coastlines within Tonga. And by the evening, after the eruption had taken place, the volcano was raining ash and tiny pebbles onto the neighbouring Tongan islands. And all of these photographs were actually people just tweeting them. So I just got all of these off Twitter, and they tweeted what they were seeing in the kind of days after the event. So the one with the windscreen there, you can see those tiny particles of ash or rocks that were falling from the sky. You can see the ash that was kind of settling on cars and on roads and on the tops of buildings in the other photographs there. Now, one of the consequences of this locally was that about 80% of Tonga's population, so about 84,000 people, had been badly affected by the disaster because the ash had meant that the water sources were polluted, and so people were struggling to get fresh water for drinking and other purposes. And one UN spokesperson said they've been affected through loss of houses, loss of communication, but what we understand is the issue with the water. Water is really the biggest life-saving issue. Water sources have been polluted, water systems are down. So this is just in the kind of few days following the event that this became a real concern. So the other major impact locally was that probably due to the tsunami, the undersea communications cable that linked Tonga with Fiji took up to 5 weeks to be prepared, and it meant that some of the Tongan communities were cut off from the rest of the world, certainly in the short term, after the eruption, because that internet cable was one of the major connections that they had to Fiji and then also to the wider world. So it was a short-term impact, but you can imagine in the aftermath of a very frightening event or an event where you might have lost property, or there might have been damage to your community, you can imagine that would be quite frightening. Now, unfortunately, due to the tsunami waves, 4 people in Tonga were killed, so it wasn't a huge scale impact in terms of deaths. There were several injuries and several people who were also missing in Tonga. But the impacts extended beyond Tonga in terms of the knock-on effects due to the tsunami. And you can see 2 images here. The one on the left is showing the amplitude of the tsunami wave as it sort of spread around the Pacific Ocean. And on the right-hand side, you can see the travel time, so how long it took the tsunami to reach across different parts of the Pacific. Just what I want to point out here is that Peru, which is located about here, the Peruvian coastline received the tsunami about 16 hours after the after the volcano had erupted, and that will become important in a moment. So I'm going to add a couple of links underneath this video so that you can watch and you can see some of the tsunami waves approaching these coastlines. But unfortunately, 2 people in Peru were killed as the tsunami hit the Peruvian shore, but it also affected parts of Chile, parts of New Zealand, parts of the United States as well. Sticking with Peru, there was also an oil tanker just off the coastline which was damaged due to the tsunami, and it led to an oil spill, and there were knock-on effects along this marine coastline. You can see that there was bird life that was killed as a result of the oil spill, so the environmental factor here being a sort of major knock-on effect on a global scale. Now, one of the things that also happened in the southern hemisphere was there was a vast increase of sulfur dioxide in the atmosphere, which the volcano had emitted, and this gas led to increased rates of acid rain. And you can see just where that arrow is pointing in the left-hand graphic, that is the location of the volcanic eruption, and you can see just how widespread some of that sulfur dioxide was. You can sort of see the outlines of Australia and New Zealand if I circle those. So Australia is here and New Zealand is here. So again, you get an idea of the scale of how much this sulfur dioxide was spreading across the Pacific. And finally, because again of the volcanic gases that had been released, there was a destruction of local food sources such as fish as a result of the marine floor disturbance that had happened after the eruption. And falling ash also smothered the coral reefs, which caused an imbalance in the global marine ecosystems. So there were other environmental consequences as a result of this. Now, what were the responses to this event? Well, the first thing that happened in the short aftermath was in Australia, Japan, Hawaii, Alaska, and along the US coast, residents were asked to move away from the coastline to higher ground. So there were warning systems that were used. Social media was used. And you've got a question about this. How can social media influence hazardous events? And one of the key things is that people can be sent messages via WhatsApp. They can be contacted via their social media platforms to alert them that there's been a tsunami and make them aware that they have to move to high ground. So that had been used. The other thing the Tongan government did was that they declared a state of emergency on the 19th of January, so a couple of days after the eruption had happened. And this meant that they were able to receive aid more easily from other countries. And as a result of that, New Zealand then started donating water. They, in the end, donated 250,000 litres of water because you'll remember that was one of the main challenges that they were facing. But one of the issues with getting some of these donations to the Tongan Islands was that the main Tongan airport had been covered with ash, and so people were removing the ash physically by hand. There were lots of volunteers doing that so that aircraft could land on the islands and distribute that aid. And overall, they pledged $1 million between Australia and New Zealand in aid to Tonga. And New Zealand also dispatched 2 naval ships carrying water and other aid supplies. Australia also, over time, donated aid. However, one of the challenges they faced with this was that up until that point, Tonga had had a very strict policy about keeping visitors out of Tonga because they wanted to avoid COVID infections, and they had thus far remained COVID-free. So there was a challenge of getting aid to the island while also sticking to the strict rules that Tonga had about COVID visitors. So that takes us to the end of learning about this exact case study, and we're going to think about the overall exam question now. You do have one final question on the side of the sheet you've been working on, which says, how can development link to prediction, monitoring and response strategies? So taking into account what we've looked at today, can you have a think about the answer to that question? Can you brainstorm that? You might want to pause the video and look up a little bit about Tonga's development and just think about what the different examples we've looked at today, how they can fit into the hazard management cycle that we've explored. Once you've done that, you can get to the back of the sheet, so just flip your sheet over, which has this question: assess the extent to which impacts of volcanic eruptions are felt more on a local scale than on a global scale. And there are 3 ways that I want you to have a go at answering this. So the first way, option A, is by just focusing on the Hunga-Tonga Hunga-Ha'apai eruption that we've looked at today. And so your structure would look something like this. Your first paragraph, you'd say, yes, local scale impacts are felt more. In your second paragraph, you could counter-argue and say, no, global scale impacts were also felt. And then in the third paragraph, or your conclusion, I'd expect you to critique the idea or the phrase felt more. And by doing that, you could say, well, felt more from what perspective? On what time scale? Economically, where was it felt more? Socially, what do we mean by felt more? Was preparedness a factor that meant that they were felt more rather than the local versus the global? Were there environmental issues, and were those different on a local versus a global scale? And what role can social media play in reducing the impacts locally and globally? Your second option is to compare 2 eruption events. So you could do the one we've done today, an Eyjafjallajökull, or you could do Nyiragongo. It doesn't matter, you pick any 2. And then your paragraph compares the 2. So you say, were impacts felt more locally in both cases, why or why not? And maybe one sentence to say what the determining factor there was. And then you've got a third option, which is to compare all 3 eruption events, so 1 paragraph each and a really short conclusion. However, you must evaluate at the end of each paragraph the answer to the question if you're going to do it that way. So you can pick whichever one of those you feel most comfortable with, and I'd like you now to use the rest of the time to have a go at planning and then writing that 9 marker. And I want you to bring it in on Friday to Mrs. Barker's lesson. I will take it in and I will mark it. I'm also going to be recording another video for you, which I'm going to give you another sheet for on Friday, which I would like you to watch for our lesson next Friday, next week on the 24th. So I look forward to seeing you on Friday. If you have any questions, just email me or pop them on Show My Homework, and have a nice day. Bye.